Hi everyone, this is David Ngo. Today I want to share with you a new feature called Hyperbola. That's what we learned in high school anyway, Hyperbola. So and it's real life application we're using in GPS, right? We're going to talk about Hyperbola, see what happened now. We start with a simple story. Uh, Normally you hear a sound slightly earlier in one ear than the other, very, very small difference. Your brain measure time different. Time different equal distance different. The different create a hyperbola. But the different how different create hyperbola. So a hyperbola is a curve. It quite point where the difference of distance is constant. It's like two open arms. This is not a cycle ellipse, right? They are different. It's not a circle, not an ellipse. And medically definition, the standard form of a hyperbola x squared over a squared minus, remember this is minus y squared over b squared equal 1. This standard form. Represent two mirror images curve. The distance by your definition, the pf1 minus pf2 is constant. P is the point on the hyperbola. F1 is focus point 1. F2 is the focus 2. We can hyperbola got two focus point. We call focus size, right? Two focus point. So I'm gonna show you a bit more later on. So compare common shape. You got a circle, got same distance from one point, right? We all know circle same distance from one point. Circle origin got the form. Let's stand for the x squared plus y squared equal r squared, where r squared is the radius. Ellipse, same total distance to 2 points, right? Same total distance to 2 points. So right there. So center origin, the major axis horizontal. Then you got standard form like. Don't forget this is the plus sign. X squared and I squared plus y squared over b squared equal 1, where I greater than b and greater than 0. They all must be positive. Because they want I is greater than b. Okay. So a semi-major axis is on long axis, long radius. B is semi-minor axis on short radius. Like one short is one long. You can go the other way now. Anyway, when you got when you buy a longitude or short, depend on horizontal or vertical. You can have a B with different value. Okay, why have polar appear in GPS? Because I was at a very satellite send time signal. Your phone compare arrival times. Arrival time different equal distance different. So its satellite pair give a hyperbola. So its satellite pair give a hyperbola. We will explain that later on. One hyperbola give many possible locations. Of course, hyperbola got two branches and branches got a lot of points. Two hyperbola narrow down. Got two hyperbola, you got some intersection. So you narrow. Zero hyperbola intersect at one point. Several here. At least four. Four. I will explain you why we need four hyperbola to get one exact position. This one is your location, right? That's what everybody location by on four factor, four unknown. Let me explain to you. Uh, Satellite broadcast signal to everyone. Each one calculate independently. No sharing or congestion, million users at one. Show why time different matter because the different they got with the which explain why we need four plus satellite to give a unique solution because we need to measure latitude x, longitude y, altitude z. This is three dimension, and a receiver clock offset. I mean the clock time. Everybody on the phone got your clock time too. So it's a satellite provide one equation so the above four unknown equations must be solved by at least four satellites. We need four satellites to get one point, which is our location. Explain it as scalability to million users. You got all the users got all different one at least got one different unknown, right? At least one different unknown. Some people overseas might have different time clock, but actual X Y Z. Everybody got different X Y Z. Okay, so explain scalability to million users. Every user can use GPS at the same time. Real life user of hyperbola, global position system, you talked about the GPS already. A global navigation satellite system like GNSS. This system is the biggest system. GPS is part of this system, right? This talk about global. Radar and radio navigation. They measure time difference of arrival. TDOA, time difference of arrival. Sound localization, our ear detect time different too. One ear detect time for sound before the others. Earthquake epicenter detection and astronomic space travel, hyperbolic orbit. That's all the real life uses. Many more. So take away hyperbola describe a different, not distance. The real world measure different better than absolutes. That is why hyperbola are powerful, are very powerful. So I want to show you now. The next one is talking what's a hyperbola look like. This is the one I want to show you. This is hyperbola. You got two arm or two branches, right? On the left is negative, x negative, the right is y negative. So we got a right branch and left branch, and you got these two line called asymptotes, the two line here. And then you got a directrix, so these two line called directrix, or we give you all this one by one. Transverse axis, got a transverse axis. You can look at transverse axis is on here, right? And conjugate axis, it is vertical line here. Like that rectum, right? Will be this on here. Go to the focus point. The center of course is the crosses center. The vertex is the two triangle here. And then the foci is two star here. Right? The foci two star here. Conjugate the endpoint is 2 point here. They all are the property of a hyperbola. I'm going to explain to you a bit more detail. Right? You will see this on later when I run the Python program. Then you can see that this is a lot of fun that you can learn very quickly. You can remember easily too. When you click on all this, I will show you later. You click animation, and then you can see the picture change, right? This will reflect whatever you want to know. Okay. So what's the next one we're gonna talk about is uh, the probability, right? A property of a hyperbola. I'll talk about this is we talk about I just mentioned that before. Now we try to explain a bit more with more detail. I just show you before. Uh, Right. So what is hyperbola? This is in the product. We consider two open arms. We talk about symmetric ranges. It describes one where the difference of distance is constant and the standard equation x squared over a squared minus y squared over b squared equal 1. This is a hyperbola. So asymptotes. What is asymptote or hyperbola? Asymptote will show you. I talked about it before. The line, the hyperbola approach it, but never touch it. The two line. Remember the cross line that never touch it. Equation. This equation simply two line, right? So one plus one is minus b on a is the function of b on a x is the equation, right? For asymptote. So you got two asymptote, one is positive, one is negative, right? Application engineering signal processing like architecture and education. This asymptote. So next one will be directrixes. The fixed line you in focus directed definition of the corners. So equation is x equal plus minus a squared over c, right? And where c equals square root a squared plus b, this will be explained later on. The application of satellite tracking optic, astrodynamic, and mathematics. Next part, the axis of a hyperbola will transverse axis direction the hyperbola open, the length is 2a, which I will explain a bit later on. Conjugate axis perpendicular to transverse of the length is 2b. This is all mathematics anyway, we can prove that. Application mechanical system, data analysis, robotic, and graphic. The center, the midpoint between the branches, foci, and vertices, we already saw the picture before. The point of symmetry of the hyperbola, application engineering, drawing, physics, graphic, and navigation at the center. So the vertices, you got two vertex, right? Vertices, closest point on each plane to the center. Location of horizontal hyperbola, I talked about the two stars before, right? Plus minus I, all this, their coordination. Application optics, structural design, and computer aided design, we call CAD, and education. The fourth side, the point two for the point where PF1 take away PF2, the absolute value equal to A, right? And this is we talk about the distance. We're using distance. That way, we use absolute value. The distance always being positive, right? The location of its focal point is plus C0 and minus C0, right? You remember they got two stars there when I showed you before. Where C, you talk about C, got square root of A square plus B square. We're talking about distance of C, right? Application optic, radar, astronomy, or acoustic. We're going to by definition, or by this point here, this, and we're going to prove why the hyperbola have a standard formula x squared over a squared minus y squared over b squared equal 1. We're going to prove to you by on this definition later on. Conjugate point and point of the conjugate x is 0 plus or minus b. That's the two conjugate point that we saw in the picture there. This do not lie in hyperbola but define its shape. Application of modeling, structural analysis, education. Rectum, the line segment through its focal perpendicular to transverse axis, like the half length of b squared over a. This one we'll talk about later on when I show you on the Python program. You can see very clearly. Application in orbital mechanics, astrophysics, optics, engineering. That's the application. So big picture summary, we got the center, it talk about the symmetry. The vertices is where the curve begin. Axis is orientation and scale. Asymptotes is long range behavior that never touch it. The hyperbola brain go very close but never touch it. It's assumed asymptotes. The foci is reflection and dynamic. Directors is the fundamental definition. And like the rectum is local curvature. That means how much bend and how they bend it called local curvature. Okay, so hyperbola combine elegant geometry with real-world application, used in physics, engineering, astronomy, and design. Understanding their product is key to many scientific fields, so that's very important. All right, now I'm going to show you how we prove, how we get a formula, coming out from here. All right, let me explain to you. A hyperbola is a set of all points P in a plane such that the absolute difference of its distances to two fixed point is constant. We talked that before, right? The F1, F2 is the two fixed point we call foci. P, any point on the curve. Definition is P F1 minus P F2 equal 2i. We said the 2i. Why 2i? Because later this constant naturally becomes the length of the transverse axis, making formula clean and symmetric. So we play a hyperbola in the coordinate system to arrive the formula to the coordinate conveniently. We send the original 0, 0, right? So the foci on the x-axis, the F1 is minus C0, F2 is C0. That's the 2 point on it. Then we let point P on Pxy on the hyperbola. So by Pf1 is the distance. Remember the formula of working the distance. And I'll work out the distance of the 2 points. This is the formula we're using, right? So this if you remember, the formula is x1 minus x2 square plus y1 minus y2 square, right? That's the formula of calculate a distance. So by a distance of two things, we said the definition, the difference of the two distance is 2a, right? That's the definition, right? Definition equal to a. So from this, we work it out. We work out the result here. We prove it. So we remove the absolute value. When we remove, what we use positive. When you remove the absolute value, we're using positive on both sides, right? Mathematic convention anyway, using positive both sides. Rearrange. We rearrange this one here. We remove the one around. So 2a plus here. We scale step by step here now. Without step by step, we end up the result. See when you square both sides, so you got this one here become square, and this one become from this 2 terms become 3 terms, right? When you square up, you end up with 3 terms. Then you cancel the common term like y square can cancel that. When you expand this one, you can cancel that as well. So you end up 4cx equals 4a squared plus 4a and square root a. So we divide by 4, got this one. Now we square both them again, try to get up this square root. So we square both sides again. So we square we are rearrange so I put I2 up here, so we square cx minus I2 square equal a square, all the squares, so got a square and this one no more square root. So expand and simplify. After cancellation, we obtain this one x square on I square minus y square and c square minus I square equal 1 when your cancellation sort. That's the result where. So we introduce B2, the missing piece here, right? We define B2 as c square minus A square, right? That means c square equal A square plus B square, right? You move around. So say now what c square equal A square equal B square. So now the equation becomes the standard form. The standard form equation of hyperbola is x squared over a squared minus, remember this is minus, y squared over b squared equal 1. If you got plus and you become a circle, right? So that's why the standard form, the meaning of the parameter is very important because symbol, a, I in here, I half the distance between two vertices. That's how, remember, half the distance between the two vertices. That means 2i, that means the distance of the two vertex, right? B is control how wide the hyperbola open. We will see that when you go to the IPong program, you will see that we will find there. C is distance from center to its focus. So relation C square equal I square plus B square. I said to you before, just move the one around, right? Where you are C square. Okay, so the key to the hyperbola is a curve where the difference of distances to two fixed points stay constant. And when placed symmetrically on a coordinate plane, this geometric rule naturally turns into x squared on a squared minus y squared and b squared equal 1. Okay, now it's all explanation. Now we go to the Python program, right? I got to Python, very long Python program, but I think that's good, important to go through this. Let me run it on first and then come back to explain to you, right? But it's very, very, it's quite long because we got a lot of features in here. Let me explain. Run the program first. This one you got put in I, we got to enter I can be any number, but make sure positive, but I just use default number, so it's easy to see. B also must be positive, right? I use one in this case as well. Rotation, we look at the animation, so put rotation, I start with 0, we can change it when you rotate it. The center X, same thing, I put X equals 0, and Y equals 0, that means the very simple form, right? That's in the center of the coordination system. Okay, look, that's the result. You see that? So when you look at the result, you can see that the two branches, right? This animation running now. For example, I got animation right, then you see the right running. Is it on the right branch? Animation will show you that it is on the curve on the right. If you put animation left, then you see that only the left moving. Okay, that's on the left branch. If I want to run both, then both them go running. Right here. So they go show you that the 2 point is on the hyperbola lines. Okay, look at all this one interesting here. You can see all the asymptote. When I click on asymptote, it will disappear. Let me get on. See the asymptote disappear. If the directrix or the directrix disappear, is that all the axes? Look at the axis. See the axis disappear. See the axis disappear. Look at the center. The center here. If I click on center, will disappear. The crosshair will disappear. That's the center. You see, if I talk about the vertices will be uh, two two triangle here, little triangle here. Click on it, the two triangle disappear. The fox side, I mean two focus point, which is the two star. Click on there, you see the two star disappear. Right, conjugate the point, which is the 2 point here. If I click on that, it will disappear. Okay, and this will be the length rectum. So remember, this is length rectum. That's what look in here. You click on that, it will disappear. Okay, so I gonna reset it. Now, if I want to remember, try to remember all the data. I click on asymptote. So what I look at. If you click on that, they will come up. That's the two line asymptote line, right? So when you click on directories, you see two directories coming out. Okay, that's where the directory is. This is a formula directory. Directory plus minus I square on C. So in this point, give you the answer straight away, right? Look at the exit. The exit coming out. See where I brought the exit coming up. Look at the center. There will be cross coming down the center. You see the cross coming out. Vertices, that's the two triangle. Talk about that here. Vertex is the closest point to the center, right? It's a very closest point to the center. And the foci, that means two focus point. That the two two star, right? The two focus point. And conjugate point, you click on that, you call to conjugate. That's not this 2 point is not lying on a hyperbola. It's not belong to not hiding, but it's just for us to draw to see the how the center of that. And like the rectum, basically, it is two line here. Went to the focus point, to like go to the two focus point and vertical to this horizontal and on the hyperbola. Okay, so you got all this is all the properties. So in this program, we can pause it. You can click pause it and everything not moving. Or you can reset it. They start come back again. And in here, you change. I show the A very important. When you move A, we make A bigger. What you expect? When A getting bigger, the distance will be bigger. Is that the distance of two focus A to A. So if you move out, the two focus will move far. You see that? See when you move I like this, the if you increase I, the distance between the 2 points getting bigger. Okay, when you reduce, they're getting smaller. Okay, B, what is B? So when you expect B, when you increase B, what happened? Increase, reduce B. That what happened? You see the look at it. When you increase B, you see the hyperbola end up getting taller, right? They're getting taller, taller. You see that, and all the points change accordingly. B, right? You can see that. So with the rotation, with the rotation, you can see that when you move it, the rotate any angle you like. I put in a 0 is the standard one, so it's easy to see. Right? If you can rotate negative side, or you can rotate any way you like. Okay, when you rotate, the thing will change. Okay, rotate 21 degrees, so the center changes and so on. Okay, what about x? The center point here. I put out x0, y0. Remember, if I move in x, increase x, what do you expect? When you increase x, that means x gonna move to the right, and all it will shift to the right. I forget. See, shift to the right. See that? Or it will shift to the right. What about if you are changing in y? If you increase y, everything will shift up, right? See that? Everything shift up. You see that? You reduce everything coming down. Okay. So this is the Python program for the output, right? Print out the output. So you can see that because a lot of features here. So consequently, you can see the program a bit longer, but I try to put in a lot of explanation in it, right? Put in a lot of explanation so that people can learn, right? You can learn. You can copy in your laptop or your computer, and then you can play with that. You can run the program or changing whatever you need to do. Let me go through the program slowly with you now. This one no, because I stopped it suddenly. That's why they end up error. I just stop a bracket, right? So what happened now? We're gonna do the one here. Okay. This program we call the purpose is to draw hyperbola interactively. Go slider, toggle, animation. You can see that. So the fixture toggle we use the formula is x squared or a squared minus y squared over b squared equal 1. That's a standard form. We rotate the angle, which I explain all the display all the center, vertex, foci side, a simple. That's what the program going to do. We animate a moving point, right? That's why I already demonstrated to you. Now look at the program itself. We got to import NumPy is a library with matplotlib as well. Right, this is where an animation because we're using animation there, and in there we use button, radio button, check button, and so on. So that's why it's quite complicated. So because it's the quite complicated this one, and I try to put it to Google Colab to run the whole lot to Google Colab so you can interact with that program. But unfortunately, the Google Colab cannot accommodate all the feature. They just accommodate the output as well, all the slide button. They cannot do it. So that's a pity. But anyway, you can go to Google Colab and say run your own hyperbola with your own data, right? And they will generate the outcome, but you don't have animation. Okay, look at the function now. We use because I do the rotation, so there is a little function to do rotation. Right, we can see the co-running rotation. All this are explanation, right? I put three code, that means explanation why this is a computer, the program do not read this part, right? Just only explain how you set up parameter X, Y array, right? X, Y array. So this is we're using this is the rotation, right? With rotation angle and radian. Okay, so in Python code we're using this. This is the Python code require to work on the rotation. Okay, is rotating was CSNP is on the packet of numpy. All right, and you train from xy2. This is another function. You see all these little function. Uh, you train from xy. This all this explanation for you, so you can see rotated by the theta degree. Translate by x0 y0. So this have so we're using local frame require 0 0. I said to you before, right? So, but if so after that we can move it anyway. When you move it, I demonstrated to you already, right? You can change it. XY array line and all this the way we explain rotation angle in the degree. So translation the new sentence and after rotation, we of course will change that. So we return the endpoint train from code in the world frame that will change what we thought. Now the Python script is using this one. That is very interesting that you're using all the function, right? You're using all the packet that you put in straight away. You give your return. You see the code only two lines, only two lines for the code, and you can transform what you want. That's the power of the programming. Then you got hyperbola. Now we got hyperparameter. This is IVT branch one to put about positive. Got two branches. What I want to draw it up. That the one got x squared and I explain already. U for x plus I see it's only the function when U for function. This is the same thing. There's audit when you go to the mathematics. They tell you branch one plus one, giving the right branch. Negative give you a negative branch with two branches, right? Parameter IB, the floating about it. We got the input IB. IB very clear, right? Parameter good the time. Real number line. So plot on the right band. That's how I try to explain it. This only explanation. If you don't write it, still okay. But the formula is very similar. Where hyperbola parameter, you import one. This is the syntax, right? It's a coding that you got to code it in to get it return x and y, right? That's why you got a hyperbola x return x and y. To compute branches, you got to how to compute the branches. This all explained to create a parameter value t to t make. All this one you got to create IBs again float. There's a number that we need to know. There's flow number, rotation degree, xy flow two. They all are right number, right? Or you can use a decimal place and so on, right? So we returned it. Now the syntax we're using explain a lot of explanation, but now here, so when you're writing program, you know TNP line space, my TN, they will return XYT, and they'll give you this is the function of the compute each branch of the hyperbola. Next one, you're going to ask, we ask input, right? See this flow input, a float mean the number, real number, right? Show a prompt with default value. If you press enter, we return default. If invalid, we print warning or return to default. We're using default number here in case somebody put an error input, right? Instead you tap up the program, now the program will run by on the default numbers in here. We design the default in here. That's got all the default number here. So, you can see that when you run program, you can show your default here. I give A equals 2 and B equal 1, right? And then rotation is 0 degree. You see that I put in before. And the XY, the center point is x equals 0, y equals 0, right? This is an input. There's a program to input, right? Ask people, user to put an input. Again, 2.0 because flow number, the flow 2.5, 2.6, whatever you want. But A long A, they are positive. All right, now we're going to draw the picture. This is a figure initial plot. This is the way to draw the picture, and we set the frame. Right, I could set title. We call the title up there, and all the special point name. Right, this is we compute initial frame. All the computer that we call let's see that got A0, B0, all these parameter here. Okay, and then we draw the line. Let the line draw very quick. And then on there we're moving point to and a point moving. Okay, we're moving one for animation. We're using this one for moving point when we're changing it when I'm moving the cursor too. So number 4 with a placeholder added for special geometry. You remember the table in the corner there with all the detail there. They all actually by This is all the syntax, right? Or all the coding the label asymptote, directrix, transfer axis, conjugate axis, like all these in the formula, right? All these in the table. So this is the way we set up the table, and you elect the endpoint or the one center, vertices, foci, conjugate endpoint is exactly the same. Just only only label. All this is called label. Put a label on the chart, okay? On the table there. So now we're auto scale because it's an auto set the exit limit to fit the current hyper not nice or something because the exit vary. Sometimes you cannot see the other two branches of hyperbola. So this is called auto scale. We auto scale make sure that we can see our result. So it is a syntax to make sure we auto scale. Whatever you change it, they will adjust it automatically. Okay, called auto scale view. Then the next one here, the slide. You see the slide. So interactive control, this is the same thing. Interactive control, that was how you can move the slide, right? Interactive slide, that's all. These are all the coding in this function. And animation mode, this radio button is a quite advanced or Python advanced. That is you always want to get how to set up these, right? It's a radio button. So using right left button, right left above, remember, I click on right left above, right, turn right left, and then we got left, and all this label down here too. The toggle, when you toggle that, all this label show you again and again. Now when you toggle, it disappear. When you toggle again, it's coming up for you. So you check button, click it again. That's where you end up the all the result there. Same as toggle label, we call when the checkbox we click. When you click the checkbox, will come out. Right, flip the visible state show all this. So the code is not much, but you got to remember. All right, this is our explanation. Okay, now the button. Talking about button, how to set out a button. The button, button port, button reset, button set. All right, these are the code to set up button. Okay, and update special geometry. We say pull when you stop pull. All right, you remember see the pull button in it. Okay, so we update special geometry, everything you updated. This is your computer, the one you buy on all the square or the formula. That's why explanation, asymptote is the function y đấy, directrix is the function here. The conjugate one is 0 plus minus p, like the rectum. You see that all the point definition explained down here. Recta right is passed through its focus point, okay, and its endpoint is align this point. You work out all the points straight away. This function compute this in local coordination, right? And transform them, rotate, shift, whatever you need to do. Okay, this is all explanation, and down here actually is the code to get it done. The code to get it done, we'll probably say choose a line train line by some current view, and then you got local 0, you got vertices, and you got foci. The foci to that means to focus point, conjugate the endpoint, that's what you got put on there, axis segment, and then you got our asymptotes, all the special property. They write up all the special properties so they can show you the result. Directors and local frame, how they display. The elected rectum point, and the elected point is up lane of the B square on A. And then you write a focus segment x equal plus C. They write it all right ranges. Left focus x minus C. You can do negative there. And let the rectangle endpoint or 2 point I showed before. So return all this result, right? All this property. So we refresh the curve. After we do that, we recommend everything from the current slide. When you want to refresh a code, we can reset that. So everything come back from the beginning, right? So that way you rescale 2 or 4. This is also all the explanation. And this is how you actually doing that. How actually we recompute upper pressure, we do everything from when you reset, we do everything back to normal, right? That way they'll recalculate it and show you the result. Okay, so when you update that, every time you update it, you got all the stated, all this you to update it, right? Focus point all the formula. Because this is a formula, whatever you got A, they substitute A in there. Whatever B, C, E, they got all the mathematical, they calculate it straight away. Okay, it's a programming. So all this on the slide, how the slide going to do? They're going to refresh the curve. We call back when any slide change. That's the function on slide. It's on mode. You call back with animation mode change, you refresh or whatever. You will rescaling it, model radio on click, click right when you port, you remember the port button and reset button, how they work. Okay, so when you toggle that, when you toggle, right, on the port, you receive an animate, right? So global port is this is the code you need to write in, and then you set up button pause, right? Click on pause. On reset, it's a reset similar, right? Reset, you got all the button reset here. We got set reset slider and mode to the original start up value. Also reset animation frame index to 0, bring it back to the original one. When you reset it, bring back in. So that full update. Well, after we do all that, we got a function. I got full update. And the last part is the animation. This is quite difficult here. This part is Google Colab cannot accommodate this part. When I upload to Google Colab, this part is not working, and they're not accepting that anyway. So they not look like they're not compatible. Okay, so this is uh, animation here. More right, both we click whatever we click enough for us, right? That we return here. So this is animation. Make sure this is animation there, right? There's instruction here, so we show the animation. All right, let's run it again before we close it up. Just remind you that you got to put in this one again. Make sure when you play with your computer or laptop or iPhone, you can put a number instead of 2. Before I put 3, right? Instead of 1, I can put in 4, 3, 2 as well. Doesn't matter. Rotation degree put 0 because we can change it later on. X or Y we can change it as well. Now we put on all 0. When you end up result, you see that I'm 3, so that one bit high up now, right? Okay, so your center point is up here. What we need to do, the same thing, we can click all the ascend box disappear, right? Directorate disappear, exit disappear, center disappear, vertex disappear, then the fox side to disappear, then the conjugate point, then the lecture return, right? So if you want to do it again, you want to learn where the asymptote, we click on there, so you straight away to your right, okay? And then you want to do directories, yeah, you click on there, you appear for you, and so on, right? Whatever you need. So this is a very powerful one that you can learn and remember. See the vertex come straight away. You see that? And the fox, see two fox are coming up and so on. And when you're moving this, then you know how it look like. If you're moving B, you know what they will look like. Okay. When you rotate it, you know, set up a position now you can rotate any angle that you like. And down here, X can move X anywhere you like. You see that? You can move Y anywhere you like. You see the hyperbola will move accordingly. Okay, I think that's long enough. I hope that you can learn the hyperbola well. All right, so you understand what exactly hyperbola behind and all the special property. All right, thank you for your time. All right, I will see you next time. Thank you.